Today's question is, what does the universe look like on the biggest scales? We're going to work our way down from the largest scale to the smallest scale, or close to the smallest scale. But to start, let's look at the entire universe and answer the question, what does it look like and what's it made of on the biggest scale? Unfortunately, the answer to what the universe is like on the biggest scale is not something we could see directly. We could see far away, but the farther we look, the less we're seeing the present. Because light takes time to travel, when we look far away, we're looking back in time. However, there's been a lot of work done in this area, and we have three main sources of information. One, we could look close by, and we could see the structure there. Second, we could look at the cosmic microwave background, and we could see the patterns there. And that's the very early universe. So somehow those patterns of the early universe have formed into the patterns that we see now. So if we can work out how those things would progress, those patterns would progress from the cosmic microwave background until now, well, we'll have insight into what the universe looks like. And third, and this really helps with such modeling, we have the laws of physics. So we could look at that initial pattern, we could input the laws of physics and see how it progresses, and we can compare it to our local world. And that's what's done, that's how these simulations are made. So let's take a look at one of these simulations. Here's a simulation of the cosmic web. The cosmic web is the name for the structure that's the biggest structure in the universe. So let's take a look around. This seems pretty simple. First off, whatever direction you look at, no matter where in space, this is what you're going to see. But what are we looking at? Fundamentally, when we're looking at this picture, and when we're looking at a lot of the different structures on different scales of the universe, we're looking at different energy densities. You see the white spots. Those white spots are the highest concentrations of matter, and those are called nodes. And they're called nodes because they're connecting to all of those more bluish lines, although somewhat whitish and somewhat bluish. The more bluish, the less dense. The more whitish, the more dense. But these filamentary structures that are coming off of the nodes, filaments. And then you see dark spots. And those dark spots are surrounded by these filaments and nodes. And those dark spots are incredibly empty, and those are called voids. So when we look at the cosmic web, when we look at the structure of the universe on the largest scale, we see three main things. We see nodes, major concentrations of energy and mass, filaments, slightly lesser concentrations, although much more concentrated than the voids. To get a basic sense of the matter distribution of the universe, the overwhelming amount of matter is not in the nodes, where you might have thought, even though they're the highest concentrations, so much more space is taken up by filaments that the overwhelming amount of matter is in the filaments. There's a bunch in the nodes, and then there's the least in the voids. However, when it comes to filling up space, the voids are the dominant one there, filling up 77% of the universe's space. So that's not particularly helpful. If I tell you that the universe is different energy densities in different places, that's very nice, but how do we get to me, you, and everyone else? And the answer is, well, it's very complicated. Let's get a little smaller. So let's focus in on the two things here that are made up of stuff, the nodes and the filaments. Of course, the voids also have stuff in it, but relatively little, and you don't have any structures in the void. In the next video, we're going to take a look at what are the nodes made of, what are the filaments made of. Until next time.